Number 3 talks about a sector of a circle. So here's a circle and a sector of it. And it's got two 12-inch radii and a 9-inch arc. And so then the perimeter is 33 because that's 12 plus 12 plus 9. What's the area of the sector? Okay, now in the last handout, we learned that the area of a sector, you could do it two ways. You have percentage of a circle's area, pi r squared, or you have 1/2 the radius times the arc length. And if you look at this, well, that formula is definitely the easier one to use here. So we could say that the area of the sector is going to be 1/2 12 times 9. So that's 6 times 9, which is 54. So the area of the sector is going to be 54 inches squared. It says to the nearest tenth. So really what we could do is say 54.0 inches squared, which means you've considered it down to the tenth of an inch, or square inch. It also asks for the central angle of the sector. So we're trying to find this right here. And that's where I think this formula might come in handy, because now we can say, okay, the area of the sector is 54. So I'm going to combine these two. 54 now has to be theta over 360 times pi r squared. And so let's see, if I multiply the 360 over, then I get theta times pi 12 squared, 144. And then if I divide the pi 144 under, then I can punch all that into a calculator over here. So I've got 54 times 360 on top, and I've got 144 times pi on the bottom. And we end up with theta being about 42.97 degrees. So to the nearest tenth of a degree, 43.0 degrees. Okay, I'm going to keep going with this one because in number 4 is a continuation. And it says there's another sector, part of a circle with a different size, a different radius, has the same 33-inch perimeter. So I don't quite know how to draw. I don't know what this is going to look like, but let's say it does something like this. This is R, R. The perimeter is 33, so the arc length would have to be 33 minus 2R, right? That's the arc length. And it encloses the same area, which is 54 from the previous problem. That's what we know about the area here. Okay, so we need to find all this junk about it. Okay, so let's see. We know that area of a sector equals 1/2 radius times arc length. So in this case, we could say radius times 33 minus 2 times the radius, because that's the arc length, and that equals 54. If I multiply the 2 over, I get 108 equals r times 33 minus 2r. And then I can distribute the r. So I'm going to get 33r minus 2r squared. And now this is a quadratic. So I'm going to make it equal 0. And I'm going to get, actually, let me bring all this stuff over to this side. So it'll be 2r squared minus 33r plus 108 equals 0. At this point, you could, I mean, it is possible to factor this thing where it multiplies to negative, or to 216 and adds to negative 33. You can try it if you like. I think it ends up being negative 24, negative 9. But at this, with these kinds of numbers, I think I'd probably just go to the quadratic formula. So that's, in this case, that would be negative b, r equals negative b plus or minus b squared minus 4ac all over 2a. And in this case, a is going to be 2, b is negative 33, and c is 108. So I'm just going to store these in the calculator. 2 store as alpha A. Negative 33 store as alpha B. 108 store it as C. And then I will just plug this into the quadratic formula. So negative b plus the square root of b squared minus 4ac all over 2a. And we get 12. So r equals 12, which was actually the answer that goes with the previous problem. Or, and then I will cut and paste this thing if I can. There we go. And I'll switch that plus to a minus. And we get 9 over 2. So 9 over 2, which is 4.5. So 4.5 inches is the other one that we're talking about here. Okay, so let me shrink this down a little bit. Okay, so actually I'll put this underneath here. Okay, so now we know the radius has to be 4.5 inches. So the arc length would have to be 33 minus 2 times 4.5. So 33 minus 2 times 4.5 is 24. So the arc length is 24 inches. What else do we need? We've got the radius, we got the arc length. Oh, to the nearest tenth. Well, these are already. Okay, and then central angle. So theta, let's do, we could do this as, we could do it a couple of ways. Why don't we do it with the arc length here? So arc length is theta over 360 times 2 pi r. So it's percentage of circumference. We know that it's 24. So it's theta over 360 times 2 pi 4.5. I could multiply the 360 over theta times, and then this thing turns into 9 pi. And then I could divide the 9 pi under. And let's see what that equals. So that's going to be 360 times 24 divided by, and you have to be careful here, 9 pi has to be put in parentheses, because otherwise you're only dividing by 9 and then multiplying by the pi. And we get theta is 305.56 degrees. So really this picture is not accurate. Really what it should look like is we're looking at a sector that does kind of look like this, but we're not looking at the small sector. We're looking at the big sector, right? The one that looks more like Pac-Man, I guess. Right there. It won't stay. Okay, here, there, that part. Where this is 305.6 degrees and the radius is 4.5. Okay, hope that makes sense.